So I have a question about the like the combination of L1 and I guess L2 bounds that you're using. So if you perhaps go back to the slide where you're showing just further back. Yeah. So that one forward. So it seems that the ridge one of these two, there's more non-zero coefficients, but it also looks more interpretable.
Yeah.
The Lasso one, you've lost the structure. So for interpretability, do you find generally that Lasso is helping or not helping?
Likely the top ones are consistent.
Mm-hmm.
And we do stack them up and compare. And for, I was talking to Tom was telling me that for fMRI, then you should go for ridge. There's physical reasons why it seems to be this more like kind of blurring effect. But for single neuron, I think the jury is out. That's why we're looking at both. So basically, if you have subject matter reason to go for one, you use that and argue for it, but not I'm just being agnostic, right? Don't want me, because my group like Lasso and Jack's group likes ridge, and then we end up two signs. That's what I'm trying to avoid. Yeah, thanks.
Kind of a related question, but really about how we should interpret this correspondence between AlexNet and the other networks and the neural data, right? So you mentioned, well, let's say over here we have AlexNet.
Right.
And it has several layers, and you mentioned that some layer correlated best with the neural activity, right? And you show us here, I think the Lasso and ridge are different ways of getting that linear correspondence. Is that right?
This one? Or this one? This is one neuron.
Okay, but
yeah.
the general point you're making is that we can use AlexNet and these other CNNs to interpret or establish a correspondence between neurons and V4.
Yes.
Okay, so here's my question. When you had one slide, we don't need to go back to it, where you showed that there was a particular layer that corresponded best. Yeah, that's right. So maybe it's N5. That course, or N2 works well used.
I think we should put the error bar. This is pretty close to variability. This is the average of 74 neurons.
Ah, okay.
Yeah, so we could put the error bar there, and then it seems it's not going to be big enough, but that's the question too, where do you cut, right?
Okay, good. So you're showing here that N2 in AlexNet predicts best V4 activity. Is that right?
This is the average prediction score, yes.
Okay, good.
Yes.
So here's my question. It's really, I like very much the idea of bringing in stability as a way of avoiding spurious results. Right. My question is more almost methodological and philosophical. It's if we want to pursue neuroscience by saying we have a computational model of a process like image processing, and we make a statement like N2 predicts best V4 observed activity, then it seems that statement depends very heavily on the form of the prediction function that we're learning.
Yes.
And so this statement is true, I guess, for linear functions, for learned linear mapping. But if you think about it, N2 in AlexNet is some function of the previous layer.
Yes.
So therefore, there exists some other function, not linear, where the previous layer would predict at least as well the neural activity in V4.
Right.
See what I'm saying? So it's
I guess you have to bring in neuroscience because the first layer, which is Gabor-like, we all agree, right? So we're basically saying that's the Gabor-like model. And before this work, we also had our own handmade V4 without much tuning parameter at all, and that's where we established the benchmark performance. So there was a earlier model still being written up that's why gave us some confidence on trying the deep learning. As you said, otherwise, how do you know this is good, right? And then also, why don't you, so the first layer, there's a good agreement by the community. It's kind of, we one does that. And anything after that, I think we rely on prediction a lot, which is also Jack's lab rely on prediction a lot. But then we try to confront this, they all do good prediction. They're not differentiating.
I see. So I guess to say it in the most general form, my point is this.
Yes.
If we can establish that layer I in AlexNet can predict the neural activity in, let's say, V4, then it's also true that we can predict from the earlier layers that same neural activity just as well if we were to compose the linear function that we had here with the nonlinear functions in the different layers of AlexNet. You see what I'm saying?
Yes, I understand that.
So
but
that's the sense in which my question is really methodological, sort of, if we want to.
We have too many models.
Right.
So other things have to come in to break, like, the reason AlexNet maybe is because people also do a lot of other work with the AlexNet and try to interpret, right? We can be all wrong, but we're kind of all wrong together. We like the deep learning network, right? And then this is just saying that can also do neuron prediction, but whether it map into any really brain regions,
But here you're showing us that, yes, it does map, right? That's what this is showing.
No, it does prediction. But as you said, I can find another unknown function maybe would do the same as prediction. And how do you differentiate the two? Right, so I'm kind of saying that there's some understanding by the community of people who kind of believe this, at least the first few layers of DeepNet might be capturing something. But I could use random forest in some, I haven't done that, right? Maybe it'll give also the same prediction, but just it doesn't quite map into the science. People don't, at least by the current knowledge, we don't think brain works like random forest. So I'm kind of bringing that as some soft evidence to say that that's why we think this is worth sharing. It's not set like a really conclusive, but kind of put it's piece of evidence pointing a certain direction. I was surprised. We did our own model, and I think I gave a talk, and Benji was after me, and I was surprised. We worked very hard for the model, for my two best people for a few years, and then this just beat it, slightly. So that's why I got on deep learning. So it's not we started from this. We actually started with something we worked very hard, and we're just surprised. This came from nowhere, and ImageNet, and then did well with prediction.
Yeah. I think this is actually one of the most interesting style of result in the last several years in
Thank you.
Understanding the neuroscience of visual cortex. But that's why I'm really, and I think it's a model for ways we might study other parts of the brain. But I think methodologically there are some interesting questions there too.
Yeah, I'm not resolving it, I know, because I'm struggling with the same. There can be other models, right? When do you stop, right? Even when I do stability, eventually I'm overfitting too, right? I need new data. So we do have movie data with V4, and that's what a lot of this would. So this is really an iterative process. And then we're going to try some of this with new colored movie data. And hopefully they will kind of differentiate a bit these different things. But this data, I think we kind of beat it to death already. There's not much, to the other layers, it's inconclusive. Yeah, but it's kind of interesting that it's pretty consistent. It didn't go down or anything, right? Right, so there's something there, but it's why? And when we understand deep learning, maybe we'll understand better. Yeah, but now yeah, that's why this paper has been making for at least 2 years. Thank you.
Let's move on, and one last, hopefully, quick question.
This is fantastic, Ben. I was wondering if you could describe a little more about the sense of stability in which you're using. Like the papers you cited talk about, uniform stability and hypothesis stability and error stability and so on. And uniform stability is very difficult to achieve. Can you talk a little bit about that?
Yeah, I'm kind of leaving it to the user a bit. So what we have done is, this is just the 6 models or 10 models we happen. So for me, it's to say, write it down. What are the stability? What are the things you're trying? So I'm trying to move there, but I'm not really telling people exactly. ESCV is a quantity you can use, right, for that Lasso, and it works for random forest. So that's a quantity people can try. It's basically look at the regression function, how stable that is. But in terms of what's the right one, I don't have answer. I think computation, so it's more like, let's have some common language we can talk about and try different cases. And then we maybe come back together and we have some understanding what type of problem will work. And I'm just trying it out with my own projects, with my students. Yeah. But kind of have the language set down. Let's say clearly what you're doing. That's kind of a big part of the message here, yeah. Thanks.
Okay, let's thank Ben one more time.